Another problem that can be solved using friction is to determine whether an object will slip or tip given a certain force. In this case, the force is not given, but its location is. You're also given the coefficient of static friction and asked to solve for the maximum force that can be used without the object slipping or tipping. In this case, we'll need to solve both conditions, the slip and the tip condition, and then determine which one is smaller. That one will occur first. After labeling all of our given forces and unknowns, notice I've called P tip because there's going to be another P which will be P slip. There'll be two different values. Next, I need to apply friction and the normal force. Now in this case, I'm assuming the tip condition first. It doesn't actually matter which one you assume first, that's just the one I chose to do. If the object is about to tip, friction is going to be applied here at the base, and friction is going to oppose motion. Also, if the object is about to tip, that means all of the force is going to be placed on this particular corner. So I can apply my normal force right here at the corner where it's going to tip, because when it does tip, all the force would be placed right there. And this is an impending motion. I'm not stating this is impending motion, but this is right before it tips. And I'm going to call this point right here at the corner, I'm going to call that point A. Now solving this particular problem is very simple for this tip condition. If we look at this diagram, there are three unknown forces and one known. We know W, we don't know N, we don't know F, we don't know P tip. There's only one force we really care about, that's P tip. So we want to look for any ways we can cancel out N or F. If we apply static equilibrium to the X direction, it's not going to help us very much because we have too many unknowns. We don't know F and we don't know P tip. If we apply static equilibrium to the Y direction, we can solve for N, but that doesn't really tell us anything. If you'll notice, I did not set F equal to mu s times N. That's the maximum friction condition, and if the object does tip, it's not sliding at this point, which means that friction does not equal its maximum value. It equals something less than its maximum value, so we can't actually solve for F. The only way to cancel out N and F is to apply static equilibrium to moments around point A. We'll then cancel out N and F, and we can find P tip by itself. So applying static equilibrium to moments with respect to point A, here's our zero statement. Once again, N and F both go through point A, so although there's force there, the perpendicular distance is zero, hence they will produce no moment. P produces a negative moment around point A, and its perpendicular distance is E. W produces a positive moment around point A, and its perpendicular distance is D. Solving this equation for P tip, now we can plug our numbers in, and we'll find that P tip equals a positive 83.33 pounds. So now we have our free body diagram crate with the slip condition. I want you to notice a couple of changes on this. First of all, I've changed P to be P slip. It's going to be a different value. Second of all, I've moved N over to the center of the object. If the object is no longer tipping over, the weight is evenly distributed across the bottom. So we're going to symbolize it with a single point force in the center. Now, the actual weight would in truth be a distributed load equally applied across the entire bottom surface, but it would be in the shape of a rectangle, and therefore it's going to be at the center. The frictional force also changes. If the object is just about to slip, friction is going to be at its maximum, and its maximum friction equals mu s times N. Now in order to solve for P slip, we have to apply static equilibrium to both the X and the Y direction. First we have to figure out what N is, then we can use N to solve for F max. Now you might look at this and say, well hey, N equals W. You have to prove that. You have to prove that using static equilibrium. So I'm first going to apply static equilibrium to the Y direction. And of course you can see here that P slip Y and F max Y both are 0. 0 then equals a negative W plus N, which means that N equals W. Once again, you have to be very careful. That's not always the case. It was not the case in the example I used with the crate that was sliding down the slope. Now we can apply static equilibrium to the x direction. W has no x component. In this case, N has no x component. So 0 is going to equal P slip minus F max. And looking at this equation, it looks like we have two unknowns, but remember F max equals mu s times N. So we can plug that in and we can solve for P slip. And once we plug the numbers in, we will find that P slip equals a positive 100 pounds. The final step here is comparing the two values. P tip was a positive 83.33 pounds. P slip was a positive 100 pounds. Since it takes 83 pounds for the object to tip, it's going to tip before it slips, which means that the maximum force we can apply is 83.33 pounds. Although the problem doesn't ask for it, I'm also including the information that at this value, at this amount of force, the object is just about to tip. So at the end of the problem, we put in that maximum force and the information about what it's about to do. This problem is very similar to the other impending condition. You basically solve for the two values independently and then you compare them, and whichever one is smaller is the one that's going to occur first in this case.